Following up with the conservation of momentum video, we have collisions. And if you haven't watched the previous video and you still don't understand like the conservation of momentum, then I highly suggest you go watch it. So either way, there are two types of collisions: elastic collision and inelastic collision. And I think you see both types in problems, so let's go over them. In inelastic collisions, the momentum of the system it's conserved because of the law of conservation of momentum. And then if it's perfectly elastic, then kinetic energy of the system is conserved as well. And you're not going to see that in the other type of collision, so that's going to be the main difference. And I'll be going over inelastic collisions in a moment because I'm getting ahead of myself for some reason. Anyways, so in a perfectly elastic collision, the objects, they're going to bounce off each other and they're going to head in whatever direction based on like their mass and like what velocity they were traveling in. And we're going to be seeing like this applied in problems, hopefully. And then we have an elastic collision. Again, momentum of the system is conserved because of the law of conservation of momentum. And the kinetic energy of the system is not going to be conserved because in an inelastic collision, they're going to like stick together, which generates heat. And I do not know why it generates heat, but it does. Okay, maybe Cass will explain that to you guys. Either way, when you see this in problems, it's probably going to be like two like train cars like heading in the same direction and then colliding, and then one of them sticks the other. And again, as I've been saying, we're going to be doing problems to apply these concepts. And I think that's about it for collisions.